Hi everyone, Cool from RunChat here. In this tutorial, we're going to learn how to use the code node to create random massing studies like this. So we're going to start by creating a code node. Just double click, search for it. It's in the tools menu. And we're going to copy our image here and we're going to paste it into the chat. So this tells our code generating agent, it just gives it a lot more context. We can write a message, but we can also talk about this image and describe what we want this thing to look like. I've set my output to Rhino Python, and I'm using Claude Opus 4.6 as the model, which is a really good coding model. Make sure you're on Rhino Python as the output. This tells the coding model a little bit about how to write good code for these different use cases. So we're going to say, let's make a random massing generator that produces a grid of options like this image, and we'll just hit go. We can make the code node full screen. And by default, we're going to be in chat view. So the coding agent is going to write some code. We'll see it stream back to us while it's doing it. We don't really have to understand anything about this code necessarily. We can just stay in chat land like this. But once it finishes writing the code, it's going to switch to both views. So you'll see your code and your chat side by side. If you want to make manual changes to the code, you can in that view. If you just want to keep chatting and refine it purely through conversation, you can stay in this chat tab here. So we're going to give it a chance for this to run. Once it finishes writing all of the code, then we can click this run button up here in the corner, and that will send it back to Rhino and run it with the Rhino script editor. So there we go. We've flicked over to this both mode now, and I'm going to click run. It's going to say number of columns in the grid. Okay, sure. Rows in the grid. Okay, sure. Footprint size, building height, subdivision. Sure. I'll just hit enter for everything. Cool. And it's gone and made a bunch of massing options. Now, the really nice thing about, and it's saved this script to here. So we save it to our RunChat Rhino plugin /scripts folder. So if you ever need to go find this script again, you can. So this has done the first, I guess, pass at iterating on our prompt. Now, we've been really minimal with our prompt, haven't really provided too much direction here at all. And that's because one of the nice ways to use the script editor is to iterate. So the next thing that I'm going to try is I'm going to say, all right, this is great. Let's combine different primitives like in the reference image. Now, the way that the code editor works is sometimes it'll just rewrite your entire code again if it needs to. Other times, if you are quite specific with what you want, it can make targeted edits to specific parts of the code. So for instance, if we said, look, we want to make this grid bigger, or we want to make these massings taller, or we want an option for configuring the color or whatever it might be, then it can be fairly cheap and cost effective to edit this code just because it's only going to actually have to output a small number of changes. It looks like in this case what I've asked for is significant enough that it's just going to rewrite the whole script. That's also fine. Again, I'm not actually sure. Oh, well, here we go. It's telling us what it's doing. So cylindrical towers, so it's got round volumes, curved Boolean subtractions, courtyard arcs, cylindrical cuts. It's doing wedge chamfer cuts. So you can see that it's inferred all of that from that image that we initially sent over. And then it's doing some cantilever elements as well. So yeah, that does sound like a fairly major rework of that initial script. Now, while it's generating, we can talk a little bit about these different coding models. So I'm using Opus. Opus is relatively expensive, but it's also very reliable. So you can see here that this complete rewrite, it's cost 500 credits. But it's likely that this is going to work first try. If you use cheaper models, they'll be a lot cheaper for sure, but you might find that it ends up costing you the same amount just because you're having to rerun things over and over again. Okay, it's stepping through all of these options here. I'm just going to see what we actually get. Okay, now we've got an error here. So it's saying random choice module has no attribute choices. I don't know what that error means. We can just click this little button here, which is going to send our console back to the agent so that it can see the logs of everything that it did. And hopefully it will be able to use that to figure out, okay, where's my error? What do I need to fix? Again, especially for, there you go, it's figured it out. Especially for the good models, this is a pretty reliable way to fix bugs. And you can also see that this time it's not rewriting the whole script, it's just editing selected parts. So this little thing here indicates that we've just got a tool call, so it's going through and replacing some lines of code in here. And once it finishes doing all of its tasks, we'll see that we have a diff in here, so we'll be able to see exactly what has changed. Okay, so it's basically gone according to my diff. It reckons it's changed all of it except for right at the start. Let's just accept that and we'll hit run. Yes, 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 yes. Cool, interesting. So now we've got something a little bit different. And move these over, we'll have a look. So now it's doing various booleans and chamfers and things like that. It's also got lots of floating geometry as a result from this. But it's definitely, I guess, an improvement in terms of a formal study over our pure voxels over here. So for this first video, that's all we want to get across. It's just that those three things: choosing the right model, prompting with images so that the model has a good idea of like visually what you want the output to be, iterating just through chat. So you start with something that's relatively simple, and especially with just a simple prompt, and then you can introduce more complexity as you need it. And if you run into any bugs, you can just send this is called the console log. So basically send the error messages back to the coding agent so that it can make any fixes that it needs to. So just be aware, using good models like this, writing relatively large scripts like this, it is going to cost you a decent chunk of credits. That Opus model is just very expensive to run generally. So if you're doing simple tasks, you can flip to using simpler models, and we'll show that in the next video.